First of all, do you guys mind if I take your picture? This is you do? Okay, then cover your face. Yeah, this is my first time speaking at a conference, and I want to prove to my wife that I actually had an audience. So, all right, thank you very much. I appreciate it.
You may not have an audience at home, but you do here.
That's right. That's right. At least somebody's listening to me, right? So welcome. My name is Channing Jackson. I've been doing software design, development, and architecture for, I guess, my whole career, really. Using Java and Spring, I've been using Java since about 1999. I started using Spring when all you had was the application context.xml file. And I've been using Spring Cloud Dataflow on Pivotal Platform since around 2016, before it was in a generally available release status. I'm a member of the Pivotal Vanguards, woo! And generally, I believe that software development is more of an art than a science. And I say that because we use words like elegant and ugly to describe software sometimes, and we don't use hypothesis or experiment. Well, I guess we do use experiment quite often, but it's an art, you know. I mean, there's always 1,000 different ways to do something, and some may or may not be better than others, and it's very subjective in nature what's beautiful and what isn't. I used to be an avid jogger and a climber. About a year ago, I had some chronic foot pain that I haven't been able to get rid of, and so I haven't been doing either of those, which makes me a gamer ordinaire. And I say ordinaire because if any of you have teenage sons that like to game, they have very likely handed me my own rear end on multiple occasions in those player versus player matches on games. I'm not real good at that. I'm in the Atari generation, what can I say? So today I'm going to talk a little bit about Spring Cloud Dataflow, just to give a brief introduction of it. How many people in the audience, how many are using Spring Cloud Dataflow now? Okay, so not a huge amount. How many know what it is? Okay, better number, good. And talk about what I mean by a data exchange, because it's sort of a term I guess I kind of made up. And then talk about our case study. So what my organization and my group at Charles Schwab has been working on as far as trying to modernize our legacy platform and build a data exchange out of something that was, for all intents and purposes, not beautiful but ugly. I'm going to talk about the decision factors, you know, what kind of deciding factors went into making the decision. When we assessed our current state, you know, how we kind of tried to distill that down into something that was manageable for us to think about. What we did as far as applying patterns to just the functional requirements in general. And then a little bit about what lessons we've learned since we started the journey. So first of all, what is Spring Cloud Dataflow? As many of you already know, it's basically an orchestration service on Cloud Foundry or Kubernetes. And are there anybody in the audience that used Spring XD before Spring? Yeah, all right, 2 people. XD stood for Extreme Data, and Spring Cloud Dataflow is basically the cloud native evolution of what Spring XD used to be. It was made up of Spring Boot, Spring Batch, and Spring Integration. And as a consequence of it being an evolution, you know, Spring Cloud Dataflow does support both batch and streaming use cases. And the main components, when you add Spring Boot, Spring Batch, and Spring Integration together, and then there's the 2 new components of Spring Cloud Stream and Spring Cloud Tasks, which are now their own Spring projects. And there's basically two ways to deploy Spring Cloud Dataflow on the Pivotal platform. The easiest way is on the left there. If you can provision a service tile, it'll do everything for you. And you need additional services in order to use Spring Cloud Data Flow. Specifically, you need some sort of SQL database, and that's to save the metadata that's related to the applications and streams that you're building. And then you also need a transport or a messaging service, RabbitMQ and Kafka being the two that are supported right out of the box. If you're going to do it the sort of old-fashioned way on the right, you basically have to download all the jar files, create the manifests yourself, use CF push to push them onto the platform, and it's a little bit more time consuming, but it's actually kind of a valuable learning experience if you're new to the whole thing. But either way is perfectly effective, and there's links at the bottom of the slide to follow the instructions for either of them. Now, what do I mean? That's pretty much it for Spring Cloud Data Flow, by the way. Now, what do I mean when I talk about a data exchange? Basically, at the very root, it's a system or a group of applications that get data from point A to point B. It does some validation or transformation in the middle. It consumes data in multiple formats, and it'll often disseminate that data to one or more consumers, and also in multiple formats. And it's, most people is probably thinking, oh, that's ETL, right? It is very similar to ETL. I think it differs in a few ways, though. With ETL, if you looked it up on Wikipedia or something like that, it would basically say it's a process of extracting data from one database and putting it into another database and transforming it a little bit in the middle somewhere. I kind of think of it more as the tightly coupled version versus a data exchange being a loosely coupled version. In a data exchange, at least in the data exchange that my group is creating, we don't know a whole lot about the sources of the data as far as where they are or what their systems of record look like. We don't have to, and we don't care. We know what format that data arrives in, and we know how to get access to it. The other thing about ETL is, it's typically talking about pulling data out of a database, putting that data into another database. In a data exchange, we might be consuming files, we might be getting the data in all kinds of different formats, and then disseminating that data to the downstream consumers in a lot of different formats. And like I said, the sources and the destinations are not necessarily databases. The owner of the exchange may not actually be the owner of the data that's traveling through the exchange. Oh, by the way, I wanted to say this beforehand, but if anybody has any questions during the presentation, please don't hesitate to just interrupt and ask along the way. I don't care about saving questions till the end. So I do think that they're materially different in some ways, and that's why I call it a data exchange. So in 2016, when we were deciding how to build our modern platform and how to get off of our legacy system, why did we decide on using Spring Cloud Data Flow, and how did we arrive at that decision? Well, there were a few deciding factors, the main one being that our enterprise architecture group told us that that's the direction we're going. So that choice was made for us, of course. But I took a look at what we were dealing with, and the things that are written up here, by the way, are in no way indicative of exactly what we experienced at Schwab. I can neither confirm nor deny any of the statements that were written on these slides. But in a lot of ways, we might be dealing with a big monolithic application that's more than 10 years old. It's got a technology stack with virtually every flavor sprinkled in for spice. Counting all of the lines of code, I think I came up with a 5.5 million line of code number or something like that on our legacy system. It was pretty ugly. It's been band-aided and facelifted over the years. And when I say strategic misalignment, I don't mean that we purposely didn't align the solution with its functional requirements. What I meant was that the technology stack that the solution is built on and the architecture of the solution is no longer aligned with our enterprise strategic direction. It's exclusively batch, it's inherently limited, and touching it scares us, right? It's exposure to risk. If it's not broke, don't fix it, but if you have to enhance it, all bets are off. Usually the person that built these systems is no longer with the company and they've taken a lot of their intellectual property with them. So what did we want to build? Well, of course we want microservices, because microservices. And we want our system to be aligned with our company's strategic direction. Future-proof, it's not really a thing. Nothing is future-proof, right? Because when this was built back in 2005, it was probably state-of-the-art, this legacy system of ours. I don't actually think it was, but that's not for me to say. But if we're talking about using industry-standard protocols and transport mechanisms and loose coupling and component-based architecture versus monolithic architecture, then we are talking, at least in some sense, a little bit of future-proof building here. Because if we're loosely coupling our systems, then it's easy to make changes to small components along the way to move along with the times, or to consume a new data source, or to disseminate that data in a different format to a different consumer. The new system needs to promote patterns. That statement for me was about trying to help our developers understand the concepts behind data pipelines and streaming, in the sense that if they saw things in a pattern that could be repeated over and over again, they could start to get used to the concepts, and it would be easier sort of for them to kind of maybe retool a little bit. It needs to address our data protection concerns, because working in a financial services industry, security is everything. It needs to help facilitate a migration toward more of a real-time data processing solution over time. So we might be exclusively batch in our legacy, but our target state wants to be entirely event-driven. Well, our new system needs to be able to help us along the way there. And finally, fast time to market, because competition is everything in pretty much every industry, and anybody who gets a new product out there the soonest is at a huge advantage. So how did Pivotal Platform address some of our concerns as far as data protection goes? Of course, the container-oriented architecture promotes isolation of applications and data. And by that I mean there's the hyper-converged infrastructure architecture, which is really, really cool in a lot of ways, because every application essentially gets deployed to the platform in its own subnet with its own firewall, and it's all software-based, and it's pretty cool. But there's other ways to do it too. You can build isolated network segments in your topology and then expose those isolated segments to the platform. And by deploying applications to different network segments, you can isolate different levels of sensitivity within your application architecture over the broader scope. Communication internally on the platform is secured via mutual TLS. If your application has to speak to a resource that's outside of the platform, you open an application security group that specifies the ports and the protocol that can speak to that outside destination, and it's as needed, because everything is closed off by default. And finally, you can achieve PCI DSS compliance on Pivotal Platform. Does anybody here have to deal with payment card data at all? Yeah, I mean, so that's a really big deal for us, right? There's 12 requirements in the PCI data security standards, all having to do with protecting that data and being good shepherds of it. And Pivotal has a really nice white paper actually on how to do PCI DSS on Pivotal Platform. So when we're assessing our current state, this is basically what our legacy application does. It consumes data, it validates it, it enriches and transforms it, and then it disseminates it. Again, very much like ETL, right? But as we're looking at our current state and as we're sort of taking into account all of the functional components that made up our system, we started to notice that things could be distilled into a finite number of patterns. And so what we really came to was that basically data comes in one of about 4 ways. It's either a file, an event, it comes from a data store. It could be a SQL database, it could be a Mongo database, it could be big data or S3. Or it could be that we're exposing a service and someone is hitting our service and delivering a data payload that way as well. And on the dissemination side, the same thing. We don't have control over all the consumers of our data. So, there's still going to be a lot of file-oriented data traveling around. Excuse me. We want to be able to publish events. We want to be able to persist that data in our own data store, or we want to be able to call services that are downstream and deliver a payload that way as well. So when we got it distilled down to these patterns, it sort of became a little bit more of a manageable chunk of work to look at. Even though it's still a multi-year project, we can start to really just distill all of the various different processes that are taking place on this platform and figure out kind of how do they fit into these patterns, and then how do we implement those instead. And so this is just basically another view of it, but in the middle there you have your data exchange on Spring Cloud Dataflow, and then our data providers are either inside or outside the network, right? They could be anywhere. We don't actually care. And likewise for our consumers. And in this case, when the reality started to hit, we noticed that, okay, well, let's take account data, for example. There's lots of different account systems. We might be getting data about accounts in a file from one system and data about accounts from a database in another. And another system might be publishing events that have to do with accounts. So we've got multiple different sources, and our functional requirements might dictate that we want to publish account data in only one way. Excuse me. So we take those 3 different sources and we create a stream within the data exchange in Spring Cloud Dataflow that can transform all of that data coming in different ways into a consistent format and publish it out using the event dissemination pattern. And so we've got a situation in that case where we can consume the data in lots of different formats and then disseminate it in one. Take customer data, for example. If you've got like a master data management system for customer information, you've only got one source of the data. And in that case, they might be just publishing events. But I want to produce a file and send it to a consumer. I want to publish an event, and I want to persist it in my own database for my own purposes. Well, in that case, you've got one source and multiple consumers, and that can all be done within the exchange. You consume the data in one format, and then you can transform it in multiple different formats and disseminate it downstream. Now, why patterns? Well, duh, but but also, like I said before, it can help make things a little bit more consumable, just in the sense that if it's a new concept, if it's a new architecture that you're trying to sell to some people or convince them that it's a good direction to go, you need to be able to have some relatively simple, consumable ideas that they can bite into. It represents repeatable implementations. Once you build a pattern, you can deploy it under many different circumstances for different use cases and just configure it differently rather than rebuild it every time. It does facilitate the speed to market. It facilitates the governance of our data lineage. So that's real important too. Data governance is huge now, right? If we know that all of our data is traveling through our system in a finite number of patterns inward, and then again outward in a finite number of patterns, it's really easy for us to be able to reconstruct our data lineage and be able to report on that data lineage even. And then it focuses the application-specific efforts. And right over here, I don't know if you can read this, but on this side I've got the patterns representing the consumption of the data and the patterns representing the dissemination of the data. Well, really all of the customization and heavy lifting happens in the middle here. Because once I build my consumption and my dissemination methods, I can just keep reusing them over and over again. All I have to really worry about is the team building this middle part here that's application specific. So it also helps us to focus our efforts of work in where they need to be. Now, what does it look like in Spring Cloud Data Flow? Now, this is actually kind of a ridiculous oversimplification, but what I did was I took, whoops, sorry about that, laser button. I took all of the out-of-the-box sources and sinks that fit our patterns, and by out-of-the-box sources and sinks, I mean Spring Cloud Data Flow comes with about 60 ready-made sources, processors, and sinks that make up the applications of a stream. And so what I did was I tried to illustrate the concept of the various different patterns coming in through a finite number of sources and then going out through a finite number of sinks. And there's like file, there's JMS, there's JDBC, S3, Rabbit, MongoDB, and SFTP for sources. Those are all, they're just configurable out-of-the-box apps. We didn't have to write them. And then on the sync side, file, SFTP, Rabbit, JDBC, S3, Mongo, HDFS. Then there's this mechanism for building a stream called named destinations. So I can have all those different sources send all of their data to this single named destination here, which is basically just a queue in RabbitMQ. And then my transformation here can take all of these different disparate pieces of data that came from all these different sources and transform it into something consistent for the downstream users. And then again down here is all of the sinks. And then this over here, this on the right-hand side, is the expression language that it took in the Spring Cloud Data Flow dashboard to actually create or construct this complicated and somewhat useless example because, well, you know why it's useless, but it's just for illustration purposes. But the expression language is relatively simple and easy to read and easy to learn. One of the patterns in detail, so the file pattern. This is our data exchange up here on the top, and somewhere in our environment we have an SFTP gateway. We don't know where our data provider is. We don't care where they are. We just know that they have access to our SFTP gateway. And we don't know or care where our data consumer is. We just know that they also have access to our SFTP gateway. Well, the out-of-the-box source takes care of bringing the data into the stream. And this has a number of configuration parameters, by the way. Things like a time interval and or even a cron expression by which it will poll the SFTP destination for arrival of a file that follows a particular file name pattern. And then once a file is detected there, it can be told whether it's going to read the file line by line and pass each line as a separate message to the next application, or to stream the entire contents of the file to the next application. And then the processors, of course, are where we do our work. There may be one or more of them. And finally, the SFTP sync, and it can be configured to write to a particular outgoing location in the SFTP gateway, and it can be told that there's an end of file marker that's part of the messages that tells it when to close off that output stream. So it can take hundreds and hundreds of messages and put those into the same output stream, and it ends up being a single file in the outgoing folder location on the SFTP gateway. Some really nice, powerful tools that nobody in my group had to write in order for us to be able to use them. So, and I'm checking my time, I'm only 25 minutes in. I went way faster than I thought I was going to. Does that happen often with the first timers? So basically, what have we learned so far in our journey, and how is this affecting how we continue to move forward in executing our strategy? The first one, this is important. So as I said before, Spring Cloud Stream comes with Rabbit and Kafka binders right out of the box. We don't have any experience with Kafka. We're not using Kafka. But with RabbitMQ, let me draw your attention over here to these sort of default configurations. The service tile in your platform may be provisioned with some particular default settings. So max length, for example, is how many messages a queue can hold. And max bytes is the total number of bytes a queue can hold. So in this case, 1,000 max length and 1,000,000 max bytes means I can have up to 1,000 messages, each 1K, in my queue before overflow or dead letter routing or any other kind of potential message loss might occur. Now, I know that RabbitMQ has some other configuration capabilities available that can help with guaranteed message delivery and the like, but that's not for this particular discussion. The other parameters, max retries and route to a dead letter queue. So depending on the way this is provisioned in your Pivotal platform, you have some limitations as far as the volume of payload you can handle at any given time, or the throughput of your stream. And there's also some bottlenecking considerations that you have to worry about, because what if your source is super fast at producing the data, but the downstream processor can't process it as fast as it's getting published? Of course, I'm bringing that up because I learned that the hard way, where I was able to publish tens of thousands of messages, but only consume ones of thousands of messages in the same period of time. And I found that I was losing thousands of messages. So, there's lots of different things that you can do. You can build a backing service that can persist those messages for you and offload those to another stream to have them handled in a better way. Reactive streams is a possibility where you can use Flux and Mono and all of the cool stuff that goes along with reactive that handles back pressure automatically. Or you can make sure that your RabbitMQ instance is configured with default parameters that really just kind of meets your requirements. And that's what we ended up doing. We had to raise our max bytes and our max length limits to something that we knew our system was sort of within the parameters of in terms of our use cases. I think also with Kafka, you probably don't need to worry about this as much. Kafka sort of has that sort of automatic persistence built into it, which is nice. Total cost of ownership, also an important aspect. This is where the developers in the audience nod off usually. But Pivotal's billing model of you pay by the number of application instances you have deployed on the platform might be punitive under certain circumstances, right? If you've got dozens and dozens of streams, all with at least 3 or 4 applications providing you pipelines, that cost per application instance adds up pretty quickly. And if you have multiple foundations in your network topology or multiple foundations across multiple data centers, you're suddenly multiplying that number of application instances by the number of foundations you have. So what we learned was to be really, really careful about the analysis that we do in deciding whether something ends up being a stream or a task. Because when you deploy a stream, those applications are running and they're using their allocated resources all the time, whether they're processing data or not. So if I have a stream with 4 apps and each of those apps has 2 gigabytes of memory allocated to it, I'm using 8 gigabytes of memory for 24 hours a day, even if I'm only processing data for one of those hours. Whereas if I was to build a task that did the same job, I could allocate 8 gigabytes of memory to that task, launch the task when it's needed, have it deployed to the platform, start up, accept its instructions, run, do its job, and then go away again. So that's 8 gigabytes of memory that lives on the platform for only 1 hour instead of 24. You can also think about building some streams that have shared capabilities in your architecture. We have an event notification stream that accepts events from lots and lots of different sources, and it will sort of be the broker of those various different events to route them to other workloads or work streams, depending on the information in the payload. And then the last thing here is we want to make sure that our streams are designed such that every app is essential. And this is pointing to the fact that there's a sync app called log, which does just what you might think. It logs whatever message it gets on the console. And under certain circumstances, that's a useful thing for it to do. But when our developers were first learning, they saw an example that had a log sync in the stream. And so they thought that that was required, and basically every stream they developed thereafter ended with a log sync, whether it needed it or not. And so, we've got 20 streams out there, all with a log sync, and maybe only 4 of them are necessary. So there's 16 app instances out there that aren't really adding any value. Finally, currency. Yeah, question.
On the previous slide, could you share some insight about the high cost of processing transformations? Sorry.
Okay, the question was,
Kind of transformations,
can I share some insight about the cost of doing various different data transformations?
Right. What kind of transformations to avoid and kind of offload to something else?
Yeah. Okay. So, all right. So that's a good question. When you think about a stream and you think about each of the applications in a stream being essentially a microservice, and each of those applications is really a Spring Boot app at the wiring level, they should do a very small atomic unit of work that knows its inputs and knows its outputs. And so something that merges 2 data sets together, or something that processes a large data set, thousands of rows or hundreds of rows at a time, might not be appropriate for an app in a stream. You really want a stream app to accept data, do something very small to it, and then pass that data on. Does that answer the question?
Yep.
Okay. Any other questions? Okay. And then finally, currency. So this was just about really kind of trying to plan for a rapid cadence of release, and that's because Pivotal does a rapid cadence of release. It renamed itself in the last 3 years. It used to be called Pivotal Cloud Foundry. Now it's just Pivotal Platform. I mean, how can you keep up with that kind of thing, right? No, but you really want to be able to try to stay as current with the tooling and the platform as you can. I mean, anybody who's ever been a developer knows that the newest tools and the newest stuff is always the coolest, right? We want to play with the shiny objects. But more importantly, and with today, with reactive coming in Spring Boot 2 and with reactive streams sort of making an emergence in this area, we have an opportunity to take advantage of that whole reactive model throughout entire data pipelines now and scale at an incredible rate. And so being able to stay current and up to date with Pivotal's release cadence allows us to be able to try to take advantage of that kind of stuff earlier in our life cycle. And so I'm just making these statements up here as a point of awareness to say, if you're starting this journey now, try to plan for frequent releases and frequent activities to try to keep up with new product and platform releases, because it's an important aspect of trying to keep up with the times. Retirement of the legacy platform. So this is actually a little bit of a sore subject. We haven't actually, in the 3 years we've been doing this, retired any major components of our legacy system yet. It's an aspirational thing, of course, but funding and availability of resources and availability of time, those are all factors that play into it. But one thing that we have learned that worked well was that we deprecate our old platform. So when we were ready to start building new applications on the new platform, we basically just had to draw a line in the sand and say, no more stuff happens on the legacy platform. And obviously we have to get our leadership to buy into that and be able to help us enforce that. But we were able to do that, and at some point in time in mid-2016, we were able to say, no more new work on the old platform. Everything happens on the new technology stack from this point forward. And we're going to have to incur the cost, unfortunately, of building that new platform alongside the old platform. So we're basically spending some time operating both platforms at once while we're trying to build this beautiful new thing and get rid of this ugly old thing. And one thing that hasn't worked so well, and basically it's because of what I just said, we need to do a better job of actually planning for the retirement of those older components. So including those in our sprint grooming, story grooming sessions and in our sprint planning, and making sure that definition of done includes turning off the old stuff and retiring it and saying goodbye, a tearful farewell, if you will. There are 3 other sessions having to do with Spring Cloud Data Flow in the conference this week. I encourage you, if you're interested in Spring Cloud Data Flow or data pipelines or streaming data, to check those out. I'm sure they're going to be great. And I will be available for questions for a much longer period of time than I anticipated. Because I'm finishing, it looks like, a full 30 minutes early. Wow. When I ran through this on my own, it took almost 56 minutes to finish. I've gone way too fast. I apologize for that. But I am available for questions. Yes, sir.
Follow-up question, like the heavy processing, more SQL-like transformations, like aggregations and stuff. What was your strategy, or what is your strategy to offload that from the legacy ETL world?
Okay, so if I'm understanding the question right, it was for large transactions,
Right, large
and
complex
complex transformations, what is our plan for implementing these on the new platform and getting them off of the old legacy? Okay, so one thing that I didn't illustrate was a big data pattern that we have. And so we have a big data environment, and where we have to do a lot of heavy lifting or intensive processing on large sets of data, that pattern involves placing the data in the big data environment first, and then using like a MapR API, for example, to manipulate or process that data there, where we can take advantage of all of the power and all of the tooling in that environment. And then once we have it done, we can use other APIs to transfer the data to where it needs to go at the end. Yes, in the front?
Yeah, I had a question about transformation. So you have disparate data types on the one side, and then you're normalizing them. So did you have to design the schema of the normalized data going out to the consumers, or was there a standard that you could code to?
Okay, so the question was consuming data in different types and then normalizing them for dissemination on the other side of the stream. Did we have to design the schema, or what was the last part of it?
Well, did you have to design the schema?
The destination schema.
Yeah, exactly.
Yeah, so in some cases, yes, we did have to make the destination schema if we were putting it into a database that matched the data types of the source. So in that sense, yes, we're cheating a little bit because we know a little bit more about the source system than we would really like to. But in most cases, we're transporting that data as JSON. We've standardized a JSON payload format for ourselves that we're using as the same format of message as it travels through each of those apps. And within that payload, JSON isn't, I don't know, it's not strongly typed, but there is some representation of type in JSON data. And so if our consuming systems can consume JSON, then we don't need to worry about quite so much what the schema is. Does that answer? Okay. Other questions? Yeah, in the back.
So I understand the technical implementation of it. What was the actual business use case? Was it like any domain A, when he requires the data from domain B, everybody in your company, do they had to necessarily come through this exchange? Was it mandatory? How was it used actually?
Okay, so the question was, what was really the business use case? So was it about domain A having the data and domain B needing it? And did everybody have to come through this exchange in order to get that data?
And was the second question, was the transformations configurable, or for every pipeline or every use case you had to write a different transformation?
So, okay, and then the second part of the question was, for the transformations and the different data, was every transformation reusable, or did we have to write different ones for different pipelines? Okay. So the first part of the question, as a matter of data governance, we have to know where our data comes from and where it goes. And in financial institutions, that's really, really important because of regulatory concerns. So yes, anyone that is going to consume the data that's represented by the line of business that we serve has to consume that data through our exchange in one way or another. So we might make that data available through a various collection of web services that will serve the data through our own replica of the database, for example. But they're still accessing it through a channel that we control. And then the second part, are the transformations themselves reusable, or did we have to write special ones for each pipeline? Each pipeline is generally handling a different type of data object, let's say. Like when I spoke about it before, I was using the example of accounts and customers. So accounts are going to have different transformations than customers are, just because the nature of the data is different. So there was a lot of application-specific implementation in each of those data pipelines that get built, not the same transformation over and over again.
So do you have to code the transformation every time, or you had a framework where you could specify do this A to B?
A little bit of both. The follow-up was, did we have to code it every time, or did we have something that was just configurable? And it was a little bit of both. Is there a question up here?
Yeah, I'm just questioning about in Spring Cloud Data Flow. Is it possible to have, let's say, 2 or 3 sources event or the H3 source before triggering the transformation? Or you need to process one by one?
Okay, so the question was, if we have like 3 disparate sources of data and we have to wait until we get all 3 payloads before we do any processing, how might we model that in a stream? So that's an interesting question. I don't think we've actually had that come up for us. You'd probably have to build some sort of supporting implementation that could hold on to the data until you knew you had it from all 3 various different sources, which would make for a more complicated system of apps, but it could still be done in a series of streams if I had to think about it that way. You can like one of the things that we did with our event notification stream, for example, was we save routing and state information in a database from that stream that we can then pull out at a later time if we need to. And that kind of thing might be able to be done in your example as well. Yes?
Was there any experience in testing or apart from unit testing, like having the entire data exchange, integration testing, feedback?
I really like that question because it really gets to that concept of shifting left in the development lifecycle, I think. I've been spending a lot of time trying to convince our QA teams that if each of these apps is sufficiently tested so that it is behaving properly according to its prescribed inputs and outputs, one should not have to test every stream that is composed from those apps once it's put into the system, right? Because if we know each of those apps is behaving appropriately and we're putting bad data through, the bad data should get rejected. But if we're putting good data through, it should make its way all the way through the stream. And so getting people sort of out of that mindset of everything has to be tested end to end has been a rough battle, actually. Yes?
Have you ever ran into like scaling issues? Like, what's your volume of data like?
Have we ever run into any scaling issues? Yes. The short answer is yes to that. Now, the auto-scaling service on Pivotal Platform is really useful in that case because you can configure it to increase the number of app instances based on CPU usage, memory usage, and now, I believe very soon, based on queue depth as well. And so in some cases, in the bottlenecking example that I talked about earlier, one of the ways that we could solve that problem was by scaling up the number of downstream processors we had in the stream so that they could concurrently handle the load that was being produced by the previous app. Yes, sir?
And just to follow up on the use case question before, this obviously can be used for like a one-directional data flow. Do any of your use cases leverage it for like a bidirectional type of data flow? Is it appropriate for that?
So the question was, this looks like a one-directional data flow. Would any use cases be applicable for a bidirectional data flow? So are you talking about like a request-response kind of a thing?
Well, the use case that I'm thinking of would be moving from monoliths to microservices and doing the data separation where you have the monolithic data structure and the microservice data structure. That as you're migrating customers back and forth, you need some type of replication technology to ensure that both systems stay in sync. Would this be appropriate for that type of use case?
So the short answer, I think, is absolutely, yeah. I mean, you know, your monolith could be both a consumer and a provider under certain different circumstances, depending on how you were to build your streams. And your system, where you're migrating to, could also be a consumer and a data provider under different circumstances. So, you know, it would always travel from left to right in a stream, but the sources and the sinks could be multiple different systems or applications. Does that answer? Okay. Any other questions? I thought I saw one in the back, but no. Okay, go ahead.
When you guys did your RabbitMQ implementation, you mentioned that you were dropping some of the is, did you guys take into consideration doing persistence with RabbitMQ? Because it has that availability.
Yeah, I kind of figured that was going to come up. He asked about the guaranteed delivery aspect of RabbitMQ, right?
Not. There's a guaranteed delivery and there's RabbitMQ persistence. Actually, it tries to this, just like Kafka does.
Okay.
It has that functionality.
Yeah.
The question is, did you guys consider, since your source is producing a lot more than your processor, did you guys consider having multiple processors?
Okay, and then the second part of the question was, did we consider having multiple processors to handle the large load? And excuse me, yes, we did. We did consider that, and we did use the auto-scaling service to ramp up the number of app instances when we noticed that it was working too hard. And there's a nice thing you can do when you're deploying a stream. You can tell the deployer how many instances of each app you want it to deploy. Yeah, and no, we didn't think about the persistence aspect of Rabbit in our environment, but if it's available to you, it certainly could be an option. Although, you're talking about using a lot of storage for something that you may prefer to build a service or an application to handle instead. Sure, yeah. Okay, anybody else? Yes, sir. In the nice blue shirt. Yeah.
I really enjoyed your presentation.
Thank you.
Tell me, is this the only breakout session you'll be part of in this conference?
Oh, no, but thank you for asking. I'm also participating in a panel discussion related to pivotal platform adoption and experiences with various different customers from different industries. That happens tomorrow, I believe.
It does.
Yes.
420 group 17A and B.
4:20 p.m. if you just couldn't get enough of me. Thank you for that shameless plug. All right, and another question in the back.
How do you manage continuous deployment in your setup, using app versioning and deployment strategy?
Yeah, so that's a good question too. When Spring Cloud Dataflow first came out, there wasn't really anything available to handle that, and in many ways we had to handle that ourselves. But now it comes with this nifty service called Spring Cloud Skipper that can be used to help automate the versioning of various apps within a stream and managing the deployment of those apps to various different runtime platforms. So, and I had one sentence related to Skipper in that installation slide earlier, but if you follow the links that are on the slides, you'd be able to tell a little bit more about it.
Did you come across any specific deployment strategies apart from what Skipper supports?
Actually, we ended up writing our own. We wrote our own Spring Boot app that would use the REST endpoints that come with Spring Cloud Dataflow to register apps, define streams, and deploy them automatically. And we were using that to deploy streams into production because the sort of out-of-the-box manner of doing it was requiring too many hands in the production environment for the comfort of our operators. So we had to build an application. Of course, automation's great, right? Like once you build and test the application, you can use it over and over again reliably. So that worked out well for us. All right. Hey, thanks everybody for coming. I appreciate it. Have a good rest of the day.